Hello guys, today we're going to talk about stack and queue. We're going to discuss mainly about the basic principles, operation of both of them, using arrays, linked lists, and application of stack and queue. But first of all, let's begin with stack. As we know, stack are based on the LIFO principle, or, for instance, last in, first out. The element inserted at the last is the first element to come out of the list. As you can see, for example, a deck of cards or a pile of plates. We have some built-in functions for stack: push, pop, and others, which are going to see. As we can see, stack uses the LIFO principle, last in and first out. They can be either a fixed size or dynamic size. Don't worry if you don't understand it, fixed size or dynamic. We're going to later on introduce them with a detailed behavior. These are the built-in functions we can use for every programming language, such as Python, Java, C, C++, etc. Stack uses built-in functions push, pop, create, to check with a boolean is it empty or not, and to check with a boolean is it full or not. Stack last in first out. As you can see with Java, we can use the void push. We start with the integer element where we can insert, or pop to remove, create to create a new stack, and to check if it's empty or not, and to check again if it's full or not. But now we're going to discuss mainly about stack using array, push using stack, from the top to the first out. As you can see for illustration, what does it do with the push built-in function? But what happens if you use pop? As you can see in the illustration, see, it moves it. But now using the linked list. As you can see from illustration, so if you understand what happened right now, it means that it removed the linked element. So the linked element which was in that index is now the top element. Just like that, you see? So first of all, the basic idea of the array implementation. First, we have to declare an array of fixed size, which later on will determine the maximum size of it. And in the linked list implementation, we will definitely maintain a stack as a linked list. A pointer variable top points to the start of the list, and the first element of the linked list is considered as stack's top. As you can see, the declaration of an array in the linked list. As you can see, we have declared the maximum size, which is 100. We have declared a function called LIFO, last in first out, with the integer element of max size. And now we have to make a stack with the variable s. While in linked list, we have created a value variable as integer. We have struck last in first out times the next element, as you said before. Now stack is gonna produce the top element, as we said before. A stack creation of an array. As you can see, the last element is pushed in, and initially -1 because we don't want to start all over again, because we already start from 0. And the linked list, of course, just really easy to implement it. Now push an element into stack. We have to create a function as an array to push. We have to put a condition of the array if the max size is equal to the top element, and then we have to print a statement there with the stack is overflowing, or to increment it and to make the next top element. As you can see in linked list, you can clearly see the new variable is equal to stack, and we have put them a condition. If the new stack is null, we have to print a statement the stack is full, and then we have to execute an exit statement. Now pop in an element from stack. As you can see from the if condition, if it is equal to -1, we have to print a statement that stack is underflow, and then execute an exit statement, or else to return the top element. As you can see in the linked list, might be a little difficult to implement it in linked list, but just start from scratch and do it all over again, because it's really easy to do it. Don't worry about it. Now we have to check with the boolean if it's empty or not. If it is not empty, we have to return the number of elements that are, or they are not, we have to return 0, nothing. Also the same in the linked list, but we can use the null definition there in the if condition. Now for checking the stack is full, still the same for array and the linked list. As you can see from an example here, for a stack using array, we have first declared the stack A and B. You have to create A and then create B. You have to push from the stack A the element 10, 20, 30, and in stack B you have to push the element 105. Then we have to declare a printf statement, print format. Printf means the print format statement. Now we have to pop A and pop B. We have to push the element A and pop the element B. And now we have to check if the element B, if the stack B is empty from all the elements. Then, if it is true, we have to declare print format statement that stack B is empty. Else, you have to return a stack B. Now, using a linked list, as we said before, pushing all the elements A10, A20, A30, B100, and B5. On the print format statement, we have to pop the element A and pop element B. We have to push element A and pop element B. And now we have to check, is B empty? If so, you have to declare a printf statement that the stack B is empty. Else, we have to return the stack. Application of stacks, where it is used. Of course, on this page visited history in web browser, in the sequence in text editor, as we can see later on. Also in Java, JVM or Java Virtual Machine, of course in XML, as later on my starting tutorial on XML. It's really easy, don't worry about it. And some indirect applications, data structure algorithm, which later on will begin with it, and covering other data structures, but in fix and postfix notations. Don't worry about this. This doesn't mean anything difficult, just be prepared with it and just be with it. Don't worry about it. In Fix, we have operator placed between operands, such as a plus b times c. Postfix are operators appear before operands appear before the operators, such as abc times plus. As you know, there are no precedence rules to learn in postfix notation, and parentheses are never needed. As you know from the PEMDAS notation, if you know it, don't worry about it. In Fix are a plus b times c, a plus b in parentheses times c, a plus b times c plus d, a plus b times c plus d, a times b plus c times d. As we said before, in Fix means inside the operands, while postfix are besides the operands, such as ab plus, abc times plus, ab plus c times, abc times plus d plus, ab plus cd plus times, ab times cd times plus. As we said, we're going to illustrate it. Oh, sorry about it. Don't worry about this. These are just some arithmetic operations, so it doesn't mean anything. Just as you know the meaning of infix and postfix, where are used? Infix inside the operands. This is important to remember. Postfix besides the operands. As we know, we can use stack for processing operators, push and pop. You can scan the sequences of operators from the left and right. You can output the operands, you can push and pop. As you know, the 8 steps of algorithms, we have to print to check the stack is empty. If the next symbol is a left parenthesis, and push it on the stack. If the next symbol in the right parenthesis, to pop the stack and print the operators until we see a left parenthesis. Discard the pair of the parentheses. Or if the incoming symbol has higher precedence than the top of stack, you have to push it on the stack. And if the incoming symbol has equal precedence with the top of stack, we use association. If the association is left to right, pop and print to the top of the stack, and then push the incoming operator. If the association is right to left, push the incoming operator then. And the 7th, if the incoming symbol has lower precedence than the symbol at the top of the stack, we have to pop the stack and print the top operator. As we know, the principle last in first out. Don't forget that. Then test the incoming operator against the new top of stack. And at the end of expressions, pop and print all operator stacks. And we must note this one. We don't have to remain the parentheses. Just the operator. That's all we need. As we said before in the infix and postfix conversion, operands to add the postfix expression, to close parentheses pop stack symbols until an open parenthesis appears, and operators to pop all stack symbols until a symbol of lower precedence appears, and push the operator down. And the end of input to pop all the remaining stack symbols and add to the expression. You can check the symbols there, the operator on the stack, and postfix strings. What does it give to us? A, an operator stack is nothing, gives A. The multiplication sign or star or times, whatever you want to call it. If we have the symbol stack both of them, we give A. And the parentheses on the left side and the multiplications or star or whatever you want to call it. And the left parenthesis gives us A, but B and multiplication sign and left parenthesis gives us a and b, plus times left parenthesis plus gives us a and b, c, and times left parenthesis plus gives us abc. The seventh, times, and the operator step, which is times, the left parenthesis plus times gives us abc. D, times left parenthesis plus times gives us abcd. Now with the right parenthesis and the operator stack, which is times, gives us abcd times plus. Isn't it cool? Hell yeah, it is. But the symbol and operator being both plus, check this one, gives us abcd times plus times. And the 11th one, e, and the operator stack is plus, gives us abcd times plus times and e. And the most comic one, none of them gives us abcd times plus times e plus, which gives us everything we said, and we didn't put any input there. So thank you for standing with me today with the stack. The next tutorial we're going to talk about query. If you have any question, please comment down below. I'll try to reply as soon as possible. I have opened an Instagram account if you guys want to create a community where we want to stay together. I mean, mainly stay together, but also check some other information about others, their help, what they need. So I will help you with everything you want or everything you have in school or you want to do the project. So thank you guys for today.